In our previous video, we saw that how the upwind method is developed by looking at the wave wave information. So what happens is, for example, if you have cells, you have different cells, then you have information on that cells, for example, Q and I minus 1, and we have, for example, Q and I, and then we have Q and I plus 1, cell number I plus 1. That's how the information travels. If U bar is greater than 0, then in the numerical method, we saw that the values, the variables from Q and I minus 1 is important and Q and I are important. Okay. And the same goes to the scheme when we have a information travel from right to left. Okay. Now the question is, how can we write this in a wave form? The wave form is where you combine you just look at the discontinuity. The wave is discontinuity. For example, here we have some discontinuity. So suppose there is a discontinuity like a Riemann problem, then we can identify that discontinuity by Qni minus Qni minus 1, and we call it as Wi minus 1 half. You may see that the Qni and Qni minus 1 are actually at this point, at this value, at this point. This may not be, let me just correct it. This may not be a grid point. The grid point will be somewhere else. So we have this flux at this point, at this entrance, you may say. So that entrance is actually, it is a discontinuity. It is a discontinuity. This is a discontinuity. This discontinuity can be identified simply by taking a difference of Qni and Qni minus 1. So it means that the numerical method we already developed was Qn plus 1i will be equal to Qni for advection equation we talk about, plus or minus u bar delta t by delta x. And if we have information that is moving from left to right, it means that u bar is greater than 0, and we have Qni minus 1. And this can simply write it as plus u bar delta t by delta x, and this quantity becomes minus Wn I minus 1 half. That's what we have numerical method for the advection equation, the wave point of view. The wave is actually your discontinuity. That is the wave. So it just says that the quantity that enters from left to right, the fraction of that, actually, that makes a change in the cell I. Okay. So we have this formula. Similarly, if, for example, I talk about u bar is greater than 0, if I say u bar is less than 0, we already discussed u bar is greater than 0. When we have u bar less than 0, then we have Qn plus 1i, Qni minus u bar delta t by delta x. At this time, the information is from I plus 1 half to I, the cell number I plus 1 to cell number I, and there is an entrance like that, and that entrance is I plus 1, it should be I plus 1 half, yes. I plus 1 half, and we can write it as Qn I plus 1 minus Qn I. That's what we have when U bar is less than 0. Similarly, the discontinuity at this discontinuity at this point is W I plus 1 half, since the discontinuity lies on the I plus 1 half. So suppose we have W I plus 1 half. It is the difference between Q and I plus 1 minus Q and I. Then we have Q and plus 1 I, and we have Q and I minus U bar delta T by delta X Wi plus 1 half. Okay, that's what we have when U bar is less than 0. This quantity will be, for example, U bar is negative, and then you can put it, so some quantity will enter on the cell I. Okay, and we earlier saw that there are two conditions. When U bar is greater than 0, we had U bar delta T by delta X. It was from 0 to 1. And when we had U bar less than 0, then we can write it as U bar delta T by delta X greater than minus 1 and less than 0. This is very much inconvenient to write it like this. Always you have to uh, think about that either the velocity is positive or negative and so on. So this actually makes things a bit mess. So what we do, we actually convert this into one single formula, so that the W is important for the wave understanding, wave point of view. Then you need to write all your formula in W, in the form of a W. So let me just draw this for you, or maybe I write the flux for you. Suppose we have, again, this is I, this is I plus 1, this is I minus 1, and then we have I minus 1 half, and then we have I plus 1 half. That's what we have. If suppose you want to calculate flux on this at I minus 1 half, so what quantity will be involved over here? The quantity will be involved over here is Q and I, and Q and I minus 1. But at one time you want to introduce only one value. The value is coming from this side. Okay, so we have a flux at nth level at I minus 1 half. It will be a combination of either the information is going from left to right, or either it is going from right to left. Okay, remember that you have a formula Qn plus 1 I, Qn I minus delta T by delta X. You need a flux at I plus 1 half, and you need a flux at I minus 1 half. And we already saw that when U bar is greater than 0, then you adjust these fluxes. So for I minus 1, we have two options to use Qni and Qni minus 1. So what I do, I write it as Qni and also write it as Qni minus 1 plus. Now we know that the flux in that case will be U bar Q and I. That should be the answer when we have the information traveling from left to right. So the next value, then the second value should be 0, since I'm sorry, it should be minus 1. It should be minus 1, since at I minus 1 half the information is from I minus 1. So what we do, we define one variable U minus, and we define U bar, which is the speed of the wave. Okay, and we also define it like this, where u bar plus is max, the maximum value of u bar 0, and the negative will be minimum of u bar 0. Okay. Now, for example, if the answer should be like this, we should know that the answer for fn I minus 1 half is u bar, and it should be what? Qn I minus 1. That should be the answer. Let me just solve it or see. For example, we have u bar is equal to 2. Then we have u plus max 2, 0. What is the maximum of 2 and 0? It is 2. And what about the u bar negative? So we have, for example, 2, 0, so it is 0. So it means that u bar is 0, it will become 0, and this will survive u, it will become u bar due to the this value, this is u bar. So we actually get our fluxes for that answer. So this is how we define the uh, flux. If, for example, you want to write the flux on the right hand side, you just replace I with I plus 1, I plus 1 by 2, and that will be equal to U bar negative Qn I plus 1 plus U bar plus Qn I. For I plus 1 half, we know that this is I plus 1, and if we have I plus 1 half, the information should come from I plus 1 on that side. Or maybe if you are not talking about the left hand side, you can just talk about from the left side. So if we have, for example, let me just solve this again. U plus is 2. It means that we have u bar, and u minimum is 0, so it is actually equal to 0. Okay, so fn I plus 1 half, I'm sorry, I minus 1 half, first I want to see this equation. We will get u plus qn u qn I minus 1, and from here we get fn I plus 1 half is equal to, when we have u bar greater than 0 for both the fluxes, I plus 1 half u plus will be u minus is 0, so we get u qn I. So you can see that we can recover the upwind method by defining these by defining u plus and u minus and defining the equation like this. Okay, so this was all about when we had u bar is greater than 0. If suppose we have u bar is equal to minus 2, it means that the information is from right to left. Then we have u plus max minus 2, 0. The maximum of minus 2, 0 is 0. That's what we have. Then if we have u minus, then minimum of minus 2, 0, the minimum is minus 2, which is equal to u bar. So fn I minus 1 half will be equal to, u minus is u bar, so that is u bar qn I, from putting the value over here. Now we put the value over here as well. So we have fn I plus 1 half. Since u negative is u bar, so that is u bar qn I plus 1, and u plus is 0. So for u bar less than 0, the information is from right to left, and you can see that the values involved are I and I plus 1 in the formula when we put that into our numerical method. So this was the generalization, or maybe I should write it here again. So that's how we can write the most general form of this numerical method is q and I minus delta t by delta x, u bar positive, wi minus 1 half plus u bar negative, wi plus 1 half, so on. So that is the waveform of upwind method, and it is applicable for both the velocities, either u bar is greater than 0 or the velocity is less than 0. Thank you for watching.